Hey guys, it's Mr. Win, and we're going to talk about exponential and growth and decay today. So we talked about the function, but now we're going to talk about specifics dealing with time, with growth and decay. So, all right, we're just going to do how do I write exponential growth and decay. All right, now look at this form. It looks like your exponential form because you have a little exponent here, you have an a, you have a b, okay? They do relate to exponential functions. Your y is going to be what's called your final amount. So whatever you end up with, final amount. Your a is going to be the same as before, where it's your initial, it's your starting amount, right? Okay, just like exponential functions where a is your initial value. R this time, we're going to call it as our rate, but here it's going to be rate of growth. Okay, because it is growth here. Notice how there's a 1 plus in R. So R will be your rate of growth. And then your T will be what's called time. All right, that's how we set it up. So in exponential growth, the original amount increases, okay, it's growing, increases by the same percent over a period of time. So that's just a formal definition. All right, let's do an example. Okay, if I look at this, the number of users in millions that belong to a social networking site can be represented by the equation y equals 1.5 times 1.40 to the t, where t is the number of years after 2013. Interpret the parameters. So we're just going to look at this equation and see what it means. So a, we know, is the number in the parentheses, right, if you need to see your equation. A is going to be 1.5. That's the initial number, right? Just by looking at the equation right there. Now, 1.40 is your rate, but it's going to be 1 plus that number, right, R. So if you want to find out what the R is, your rate, right, the number of users, all you do is you take your 1.40 inside the parentheses, all right, and we're going to subtract 1 from it. So if I minus 1, it's going to give us 0.40, and then convert that to a percentage. Okay, so if you're going from a decimal to a percentage, okay, all you do is you take your decimal and move to the right twice. It's going to be 40%. So the number of users is going at a rate of 40%, where your actual R value will be 0.40, okay? All right, so yeah, it's growing by 40%. So in 2023, there will be how many users? Well, you started at 2013, right? To 2023, that means time will be 10 years. Okay, so if I plug this all in to get your final amount, we're 1.5 times 1.40 to the 10. All right, this is something you can plug in straight to the calculator. And I don't have it here to show you, but if you plug it straight into the calculator, it would give you, let's see, raised to the 10, 43.3882 users. All right. All right, and that's probably in millions, so, or whatever, thousands, who knows what it could be, but yeah, 43.3, just plug it in straight to the calculator. All right, looking at example 2, the price for a radio station begins with a $100 gift card. So we know your initial value is going to be $100, right? You're starting with that. Once a day, a name is announced. The person has 15 minutes to call, or the prize increases by 2.5%. So when you have a decimal, when you have a percentage, you always have to switch it to a decimal. So if you have the percentage 2.5, right, I'm going from percent to decimal. You move it to the left twice. So left to the decimal points, okay? So here it goes 1, 2. That means there's going to be a 0 here. So 0.025, all right? And then your actual B value, your rate, is going to be 1 plus 0.025, right? So then it says for the next day, how much will the gift card be worth if no one wins after 10 days. So t is going to be 10. So our equation is going to look like this. Y equals 100 is our starting amount. In parentheses, we'll have 1 plus 0.025 raised to the 10. Plug that straight into the calculator. You should get 128.008. So roughly $128, right? Okay, so about $28 after 10 days, 2.5% every day. It's not bad. All right, let's look at actual decay. So if I turn to the backside, formula looks kind of the same. The main difference is the minus in between. You're decaying, so it should get smaller, right? So think of growth as 1 plus, decay is 1 minus. So y are still the same. Y is still the same final amount. A is still your initial amount. All right, and your R, instead of growth, it will be your rate of decay. All right, and again, it's always a decimal. All right, so you got to do decimal. You can't put it in percent. So t is going to be your time as well. All right, and in exponential decay, the original amount decreases. All right, that's going to be your formal definition here. Decreases by the same percent over a period of time. All right, look at examples. The percentage of area in the U.S. not covered by a cell phone provider can be represented by the equation y equals 0.15, in parentheses 0.45 to the t, where t is the number of years after 2012. Interpret the parameters of the equation. So our initial value, your a, we know is going to be 0.15. All right, always a number in front. All right, and over here, your rate is 0.55 because 1 minus 0.4, and this is a typo, but 45. All right, so if I take that 0.45, right, and I know it has to be 1 minus that, okay, then what is 1 minus 0.45? Well, 0.55, and when you're converting to a percentage, you're going to go to the right 2, so 1, 2, it gives you 55%. So again, if you're going to percent, go to the right 2. If you're going to decimal, left 2, okay? The number of users is decreasing at a rate of 55%. R would be 0.55. In 2022, there will be how many users? Well, from 2012 to 2002, time will be 10 years. So if I plug that into the equation, y equals 0.15, 0.45 to the 10, straight into the calculator gives you 0.000123451. Okay, looks like a pretty small amount, but it's decreasing by 55% every year. That's a lot. All right, let's do one more example. The population of Campbell County, Kentucky, has been decreasing. All right, you want to look for those keywords. It's decreasing, so you know it's going to be decay, at an average rate of 0.4% per year. All right, so you have a percentage automatically in your mind. You should think, I need to change that to a decimal. So we're going left 2. So 0.12, that is 0.4, okay? Oh, wait. See, I almost missed out on the 0.004, right? Yeah, 0.004. In 2010, the population was 88,647, so that's obviously where we start. Your A, write an equation to represent the population since 2010. Predict the population in 2020. So we know T is going to be from 2010 to 2020, 10 years again. All right, so your equation is y equals, remember your A first, 88647, times your rate. We know it's decreasing, so it's 1 minus that percentage, 0.004, raised to the amount of time, which is 10. What would that give you? Go to the calculator, 88647, parentheses 1 minus 0.004, raised to the 10, gives you 85,164.3, and that's your answer, right? It is decreasing, right? Did the number go down from 88 to 85? It's always a way to check. If you're getting something really weird, be careful there, all right? And that's about it. All right, thank you.